All right. So thank you everyone for choosing to be here instead of enjoying the nice balmy weather outside. It's in the middle of summer. So again, thank you for your time. Just to provide a little bit of introduction, I would call myself a lifelong learner. On my weekend, I spend my time with my coworker here, with my dog, doing a regular study group, both in the Twin Cities Deep Learning and our study group. And in terms of my daily job, I work as a contractor for a financial services company. Um, I type furiously, just like that cat. And in full disclosure, the presentation is definitely not based on my day job and done outside of the work hour. So nothing confidential is going to be disclosed here. So with that in mind, I really feel that data visualization is really something that I'm super fascinated about. As someone where English is my second language, it can be quite difficult to explain like my life in my PhD in chemical engineering. I work with this material catalyst called zeolite, and it is a synthetic material that I micropress, but just explaining in words can be difficult. So instead, what I usually do in a presentation is to show this movie where I say, hey, there's this silicon where it's yellow is silicon, the red is oxygen, and it has all these AB structures. And that's the catalyst that I'm working in the computational world. And then second of all, too, in my postdoc, as I work with people, advising students and doing natural language processing collaboration with a startup company, building a front end, and in this particular example, a Flask project where user can do some n-gram analysis where you want to look into a unigram or a bigram, which is two JSON word, or even a trigram. It's always nice, and it always draws me to like show, hey, this is how artificial intelligence, this is how work that is super abstract can be seen in a two-dimensional world. So with that in mind, this is going to be my take-home messages. First one is we want to use prototype to explore data and models. And second of all, we want to use prototype to convince. What does that mean? So let's dig deeper. First thing is the word prototype. When I think of a prototype, let's say, I want to build a car, fun, convertible, you can ride in a nice, balmy summer, just like tonight. Um, you don't want to start by building something that are just like, all right, you have two wheels. You also want to build something that can easily use, but it's also simpler, such as escape. So in Google, we can see that the definition of a prototype from Oxford Languages is that it's a first typical or preliminary model of something, especially a machine, or in this case, a software from which other forms are developed or copied. So we talk about prototype. Now let's discuss data actualization. And I use the image of an investigator, a he or she or they, where we want to understand what is data. And we have heard this famous quote, data is the new oil, by Clive Humby. And we keep on harping on this idea that, data is valuable. And where did that come from? it came about 15 years ago, and that has been hyping up in the era of artificial intelligence. But before we dig deep, as kind of like oil, there's this person named Francis Anscombe back 1973, which is 33 years before 2006. He talks about the importance of visualization. And there's this famous case called Anscombe Quartet. Um, and the main message is that summary statistics is really not enough. So in order for me to show what that actually means, I'm going to use a package called panel. This is something that I try to explore. So let's dig right into it. 1 second. So we have a Jupyter notebook. People love, as a data scientist, I love using Jupyter notebook just because it's easy and people can definitely reuse it over and over. And so here I'm just importing a bunch of packages. Here I'm going to read the CSV file, defining certain functions, and finally typing all those code with only 55 lines. I can show what that looks like in the new window. So Anscombe Quartet just shows, all right, if we do the summary statistics, the average, the sample variance, correlations between X and Y, Y1, Y2, Y3, Y4, all of them are pretty much the same. Just like, okay, what's happening here? In order for me to learn more, I'm going to open this up and just show the data frame. So let me do it again. And as soon as the program starts, it should go. 1 second. Why is it not working? There you go. So here on the data frame, we can see that there's these data, Y1, Y2, Y3, and Y4. All those 11 data sets are different from each other. And for X4 in particular, the X values are different as well. That's not enough, right? We can see that those are different, but what does that actually mean without any visualization? So I just uncomment that, run it, and let me close this first. Yep, and save it. We can now see the data set, right? For Y1, we can see it's going up. As X goes up, Y goes up. So it's a straightforward linear correlation between X and Y1. For Y2, instead of a linear correlation, what we're seeing is that this is more of a quadratic trajectory. And even though the average, the sample variance, and the correlations are the same, the data are completely different. Now let's look into Y3. For Y3, this provides an example of how just one outliers and the smaller sample data set, it can derail the average, the sample variance, and even the correlations. And same thing here on Y4, where it's definitely not linear, but the fact that there is this one outlier all in the boondock resulted in the average sample variance and the correlations to be the same. So that's the fun of Anscombe's quartet. Just to dig deep a little bit more, right? We can see that it is being done by using column and row, and it really did. It's super simple, right? You just say, I define a function called data frame, and all the data frame is just a copy of a pandas data frame. And here we are plotting the file just by a couple lines using a scatter plot that shows what the X file is. We can easily do the plotting using bokeh. So now, all right, yeah, those are just 11 data sets. What if we go into big data, right? That's what we're all about. In big data, here I'm going to use a New York City taxi fare data set. There are 11.8 million values that shows the pickups and drop-offs from a specific month, which is January 2015. That's the one that I picked. And here we go. We go here, halt, and we go to New York City taxis. And let's open the dashboard. And it's really 35 rows of code. I enter, go around in the background, and as we go, we are showing it on new windows. And there you have it. These are 11.8 million data set on the New York City. If people are not familiar, the set of block over here are the Central Park, and one location that I like to look into is this Columbus Circle. So let me just scroll all the way down. And that's a lot of data still, right? But I can play around whether I want to have the map a little bit lighter or darker. I can choose different color here. Let's stick with fire. And now these are the hours. It goes from 0, which is essentially midnight, to midnight. Now I like to do it for 4 hours increment. And what we can see in between midnight and 4 a.m. in the morning, it's not many people going into Columbus Circle at midnight to 4 a.m. So we go in, and as you see, I'm moving the cursor, and as time progresses, we can see that there are more and more people dropping off on Columbus Circle in the evening as opposed to the morning. So that's something kind of cool. Now that's tourist attraction. Let's go to business side. So the business or the financial district are located down below. So these are the financial district area. Come on, if this is going, there you go. So there is this huge giant building, right? And as we can see, all throughout the data set, there's a lot of people over on this side of Manhattan or New York City. If we go on in between midnight and 6 a.m., there's not that many people wanting to go to this specific location. But what's interesting is that if you choose a pickup location, there's still a few people trickling out of the office in between midnight to 6 a.m. And as we can all see, Wall Street, never really sleep on these particular day. And if we go back to the drop off, we can go in, and as time progresses to 8 o'clock, 9 o'clock, all the way to like in between 6 and noon is the prime time for people and employees to come to the office, which of course is different now in the pandemic time. So the drop off definitely tapered off, and really the highest time frame for people to be dropped off on this location is in between 6 and noon. In terms of the pickup, well, people are not leaving the office in between 6 and noon, but instead what we can see is that people starting to leave the office around 5 p.m., 1700, and all the way, even 8 looks more populated than 5 p.m., or even in the wee hour of 6 to midnight, that looks pretty populated. So that's super cool, right? Being able to look into data by just going and running really 30 some lines of code. And okay, it's kind of nice. I can share it, or I can share it using just the share screen. But what if I want to deploy it and then share it with others? So let me show you what that look like. So I put it in the binder, and if you are interested in looking into, hold on 1 second. You can take I do not want to do that. I want to Control C. Can feel free to play around with it using this tiny URL. And essentially, what I'm doing is I'm putting the notebook on my binder, and what's different is the fact that the data is located in my hard drive right before. Now, instead, I'm going to pull the data from remote location. I grab the data from AWS, Amazon, and so I'm just going to do the exact same thing here. So let me run this. Let me see. It can take a while. Blah, 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 because the total data for NYC taxi white.parq is around 390 megabytes. So that's what I'm doing. As time goes on, we also pretty much copy and paste from the local hard drive to this secure or remote location on my binder. A couple interesting fact, right? The fact that we use 11.8 million data set using pandas data frame can be very sluggish. So as we can see here, we are using a task data frame in order to grab the data. And another interesting thing to look at is that using this dot parq. Parq is a more recent way to wrap the file so that it's a little bit easier to save and to load. And that's what that would look like. So that's the fun part of showing it on a notebook. But in order for us to show it in more on just the panel, you can also do that by importing a certain package, which I can talk about later if you're interested. But here, instead of just a Jupyter notebook, I can show a nice, what they call Python dashboard here on my binder. And you can also take a look at it by grabbing, hold on one second. You can copy and paste it on your computer and you can play around with it. So that's a data, right? So now we talk about data. Let's go and explore some models. And one fun ways to explore models is by doing a number identifier. What does that mean? As a number identifier, let me do this. Let me close everything and leave page. Let me close. Hold. I'll go into here and again, I am running now on a Jupyter notebook locally. I have two different files, two different models. The first one is using a K nearest neighbors, and the second one is using a deep learning method called convolutional neural network. And all these particular set is just grabbing all the models and then saving it into different objects. One is model, second one is model underscore CNN. And with 14 lines of code, I can run locally what we call digit recognition. So let me see here. Let's do one. And I have the choice to either do a K nearest neighbor or a convolutional neural network. Let me submit this. See, that's a 6. That's absolutely not a 6. So let me try with something that's better, which is convolutional neural network. Hopefully, yes, it gets into 1. And let's do for 2. Okay, not good. We see that in the K nearest neighbor, it shows a 7, but hopefully in the convolutional, it'll give you still. So that's an example of when we are trying to interrogate the model failed. And what we can see or what we can do in this particular instance is we can click on this button called flag. And what it does is if we go into the Python code, we have a picture of that 2 saved in our home location, and we can then play with the model some more and do more training essentially. So that's a 2. So I'll just do a 3. It's not a 1. Let's see on the convolutional. Yes, it does it. So those are just some fun example that we can do. And sometimes, again, it's a prototype, so sometimes it's not showing nicely, but it says 5, so that's good. And so in this case, k-nearest neighbor and convolutional neural network was able to capture those data correctly. So let's do a 6. There you go. No, that's definitely not correct. And nope. So those both in this case, both model fail. So we can definitely flag this. So, all right, let's save this value for further research. So let's do 7.
Question,
Yes.
what did you use as a training data set for this? Was it your own handwriting?
Yeah, I will talk a little bit more on how I trained the model.
Okay,
So,
thank you.
Thank you so much for the question. And then here we can do a convolutional. So that's 2. Just like, okay, those are not good. We can again flag these and do 8. Hey, that do well. That's 8. Nope. And still this like fails. So here we can see that just by running a small lines of code, 14 plus 8 plus 7, we can really see how easy it is to prototype using this particular package called Gradio. And another cool things that people have done in Gradio is, let me show another one, is playing with, let me turn the sound a little bit lower, is what they call Spleeter. So we can do like these are audio with so we have those data, right? We have instrumental and we have vocals. And if I were to say, all right, let me run this on vocals. So let me submit that. It'll do some thinking and it will provide an output of just the vocals.
It always seems like time stands
Okay.
still when I'm with you.
Not the greatest vocals. So we can just do it if we want to grab the accompaniment and say, for example, you want to rerun the vocal, you can definitely do that. So those are some fun projects that people have done using the Gradio app. Now I've showed you, how I play around with the model. Now let's talk a little bit more on what would I use. I use a type of machine learning called classification. And on this classification, I use multi-class classifier, right? Where we pick between 0 and 1, and 2 and 3, etc., all the way to 9. And for the k-nearest neighbor, just a quick overview of what the model means. It's, we classify points based on the similarity of their surrounding. So k is just the number of nearest neighbors that we pick. So this is an exercise that I grabbed from practical machine learning in R, where, all right, if we have a new data set, which is this black square, when k equals to 1, what would the class label it as? And does anybody want to try? We have 30 seconds.
circle.
Absolutely. Thank you so much for the answer. So, right, the black rectangle really try to find what's the nearest neighbors, and the nearest neighbor in this point is a circle. So this black square would then identify as a circle. And then if we say, k equals to 3 and k equals to 3, they'll say there are 2 stars and a circle. Which one would they pick? A star. So here also, k equals to 7, 1, 2, 3, 4, 5, 6, 7. They see there's like 1, 2, 3, 4 triangle and 2 star and a circle. They would then pick a triangle. And when we pick k equals to 15, which 7 plus 1, 2, 3, 4, 5, 6, 7, 8, 8 pluses, then we can say that there are 8 pluses plus 7 other things. So the black rectangular will definitely say that they are a plus, even though it's definitely not a plus. So k nearest neighbor model is a super simplistic way of running artificial intelligence. So if you are interested in what the data look like, let me show you. MNIST data set. So, all right. Stuff, grab the MNIST data set and looking into here. And so this is what the data set looks like. Again, it's kind of hard to show a little bit on what all those mean. So I created a little bit more refined. Again, we're talking about prototype. So we are refining it some more. And I'm going to have the user choose which kind of digits that they want. So if they want to see the first 100 digits of the 0, that's what all the zeros would look like. For ones, this is where all the ones look like. The twos, this is where all the twos look like. The threes, this is what all the threes look like. Four, etc., etc. Of course, right? So we can then go in and think a little bit more. All right, what can we do here? Now, the model that I did is in using the k nearest neighbor. Again, same thing. I grab all the data set and I split it with the 85% and 15% training. And then from the 85% training, I split it some more to go into 90% training and 10% validation so that I can run cross validation and try to score it. This can take a while. And what I get, just interesting, is when k equals to 1, as in like when they see the first that is the closest one that has the best accuracy. And so with those in mind, I'll just run it a little bit. Okay, and then I think you can see the pattern that it will go down. So I'll just stop for the sake of time. I don't want you to wait a little bit more. And okay.
It's interesting, Atun, that it was saying it was 97% accurate, but obviously in
Absolutely.
your testing, it wasn't even close to 97% when you were using it.
Yes, absolutely.
The validation data that it was going against, that it was validating.
Right, but
higher.
Not only that, the fact that k nearest neighbor is probably like one of the simplest artificial intelligence model out there. And what's interesting is like Okay, if let me show you a little bit more on the data set. It's not showing, but if you see all the data set, what it's showing is that all of them are centered. It's really like deep centered on the data, right? If I do like, okay, 0 to 1, right? All these data are very much in the center. But as soon as I change the coordinate, right? The 2 is a little bit off center, 6 is a little bit onto the left, 7 is a little bit up, 9 over there. It screws all those models. Again, like what's hidden behind all these things is that yes, model works really well when you are trained on a certain data set that are super similar. But as soon as the data gets a little bit off kilter, yeah, the model does not generalize well. And that's one of the weakness of the traditional machine learning, right? So that's why we go into the art of deep learning.
Yeah.
So yeah, and this is all trying to evaluate. As you can see, the precision, the recall, the F1 score, all of them are amazing, right? 98%, nothing below 80%. But of course, when we are dealing with the real life model, that's definitely not what it looks like. So
Yeah, makes sense.
My question to Atun, back to my question a few minutes ago was, did you
Yes.
handwrite that training data set, or was that manufactured?
Right. So the data set comes from MNIST. So MNIST is the National Institute of Standards and Technology. So they have this repository of handwriting that people have done, and they digitize it and they save them. There are about 70,000 of them. So 60,000 are being saved on the training, and then about 10,000 are being saved for the testing. So that's where the data set comes from. So these are just some example of what they call the MNIST data set. Does that answer the question?
So they're all handwritten, but they're not handwritten by you.
No, it's not.
Right. Okay.
Yep.
And if you use the validation data set, I mean, it matched pretty well, didn't it? 97%.
But still, right? It proves the point that just using something simple as k-nearest neighbor is is not sufficient, even though the data shows that it's nice. But when you prototype the model, you can definitely see that there are some weaknesses on using something that's super simple.
Yeah, agree. Thank you.
Yeah.
One possibility would be to do data augmentation, right? Maybe it's
exactly. So thank you, Yanni, for sharing that. So let me go and let me talk a little bit more about data augmentation, right? So one thing that we can use prototype is, all right, yeah, I'll do image too. And this is using Sketchpad, yeah, blah, blah, blah. We can also do what we call image to label interface, right? So I can, this is just an example. I can pick k-nearest neighbor. We can say, all right, that's one. But let's use one that I created earlier. This is, I'll just drop and drag. Come on, it shows. For the k-nearest neighbors, it says that it's a 3. It's not right. And the convolutional, hey, convolutional say it's a 1. So what's wrong with this data, right? The k-nearest neighbor see that when it's tilted a little bit, there's something wrong. So we need to supplement the data with more tiltedness. And why is that? We can, using the prototype, we can see it by, let me do here. No, let me submit this. See, K nearest neighbor. I'm just rotating this data set, the one, a little bit to the right, and what we can see is that, hey, the model K nearest neighbor can definitely see that is a one. Now on the convolutional side, they see that is a five. So there's something wrong with the convolutional model now. So what this whole prototyping does is really just trying to interrogate. You want to investigate as much as possible on your model and trying to understand what does that actually mean. And again, I'm just using this and cropping it so that it looks square. And if I submit, hey, it's a one. Hopefully the convolution equals to one as well. So yes, so that's the beauty of playing around with prototype. You can learn so much by just using these tools to investigate, to understand, to make your model better. So with that in mind, let me see, where am I? Yeah, so again, k-nearest neighbor uses a Euclidean distance to measure length. So of course, if it's there's disproportionate impact when you have donation of 5,000 and 6,000. Excuse me, the donation feature can overpower. So again, scaling or normalization can be done to solve this problem. But this is the map of machine learning. As in the traditional one, right? We are just barely scratching the surface for the image classification. We haven't gone into the black hole of deep learning, which is a lot more nuanced, a lot more complex, and it really does not necessarily play just for a linear model, but also a non-linear model. So just a quick, I'm not gonna go deeper into what convolutional neural network is, but that's what it looks like, right? You look and then grab a certain values, and you really want to scan them all throughout the rasters of pixel. And and really what I did for this gradio, I just grabbed a data from, let me see here. Nope, 1 second. I grabbed a model that has been created, and this is part of the training from Google. I'm not gonna run it. It's just showing, all right, we grab all these data, can take a look at the data, and here are the Keras model, right? You have the convolutional 2D network. We're going to flatten it and then put it into 200 dense layers and then 10 dense layers. And that's what the model would look like. And finally, we use a learning rate decay, as in like, okay, the first cycle that we're running it is going to be 0.01, and it'll slow down to 0.06, 0.04, all the way to 0.000101. And if we train and validate the model, we can have the loss, the validation loss. And finally, I save it as mscnn.h5. And that's what I have in MNIS Gradio as well. Let's see, right? MNIS CNN5. So those are some fun thing that I can run on my local. And of course, you would also like to play around with it on the web. So I created, or let me see here, where is it? Created Gradio that you can also play around. So nope. Copy link. So these are the notebook. But what's cool is that once I run this, blah, 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 it will take a little bit. Just by using the free resources that Google provided, you can then share it with other people for 24 hours in using this Gradio app. So just wait a little bit. So this is downloading data, working with the data, blah, blah, blah. And yeah, if I copy and paste it on the chat, you can definitely see the same type of prototype, and you can share it with other people. So
Wait.
see.
Are you deploying an app
Yeah.
from Colab?
Yeah.
Oh my gosh.
So
But you said it only works for 24 hours, right?
correct, right there. That's a caveat, but still, it's pretty cool.
Very
Oh, that's
cool.
pretty cool.
All right. So those are the two packages that I am sharing with you. So let me hopefully the presentation is showing. So the last thing is really trying to prototype to convince, right? I'm sure you've seen, the past few years, back in 2018, this is the story of enterprise machine learning. 3 weeks to develop the model. It's been close to a year and it's still not deployed. And of course, the rise of what they call ML ops. We have the ML code here in the middle, but we have to worry about the data collection, the configuration, serving infrastructure, future extraction, data verification, monitoring, analysis tools, process management tool, machine resource management. AKA, it's a lot of money to build something like ML ops in real life. And this really comes from the Google paper, the hidden technical debt, right? So to overcome all these things, let's start something with agile prototyping. Start something with simple, right? We want to create something that people, other data scientists, some business user can definitely see in real life, something that looks like a skate. And you can play with a Segway, and then you can go into bicycles, a motorcycle, and finally a convertible car. So let me go back into this quote. Data is the new oil. But then someone named Michael Parmel came back and says, yes, it is valuable, but just like oil, right? If it is unrefined, it cannot really be used. Just like oil, as soon as you grab it, you need to do some distillation and you get the ethylene, you get the propane, you get the butane, and all the way you need to really play around and then do a lot of extractions. So most data be broken down, analyze it for it to have value. So that's my convincing. There are other packages that people can do. One of my favorite is Streamlit, which I didn't really share today, but it's something that I like. There's Django. Django is definitely a more traditional front-end app. There's a Flask, and that's another web development. If you enjoy D3 and JavaScript, Observable is a really great package that someone can use. And so with that, thank you.